Today we're going to look at linear equations with two variables. For example, I have the equation 2x plus y equals 4. So a solution to this equation is actually going to be two numbers, an x and a y. And we typically write these solutions as ordered pairs in parentheses. We always put the x first and then the y. So in part A, they're asking, is the ordered pair 2, 0 a solution to this equation? First, that ordered pair is giving us the information that x is 2 and y is 0. If this ordered pair is a solution, that means when you take the equation 2x plus y and you replace the x with a 2 and replace the y with a 0, if it is a solution, that will be a true statement. And in this case, I can see when I plug in 2 for x and 0 for y, I'm left with 4 on the left equals 4. That is a true statement, and so my answer is yes. The point 2, 0 is a solution to this equation. We can do the same thing in part B. Is the ordered pair 1, 1, so x is 1, y is 1. Is that a solution? Well, I would take the exact same equation, 2x plus y, and replace the x and the y with 1. This time on the left, I get 2 plus 1, which is 3, and 3 does not equal 4. Because I have a false statement, 3 does not equal 4, the answer is no, the point 1, 1 is not a solution. All right, let's look at one more example. We've got the ordered pair 3, negative 2. So x is 3, y is negative 2. To determine if that's a solution, I replace x with 3, y with negative 2. That gives me 6 plus negative 2 on the left, and that is equal to 4. So once again, I'm left with a true statement, 4 equals 4, and so the answer is yes. So linear equations with two variables can have more than one solution, and in fact, they end up having an infinite number of solutions. There's an infinite pair of numbers that will give you true statements when you plug them into the equation. Now, if I give you half of the solution, we can find the other half. For example, in example 2, we've got the equation y equals 3x plus 4. I have a table of values with x's and y's, and I want to know what is the missing value in each place in this table. So the first column of the table of values says x equals 0, and the y is blank. So I want to know what y value goes with an x value of 0. To answer this question, I'm going to replace the x in my equation with 0 and then solve for y. 3 times 0 is 0, 0 plus 4 is 4. So I get when x is 0, y is 4. That tells me that the ordered pair 0, 4 is a solution to this equation. I can do the same thing for the other pieces of this table. If x is 2, I'm going to plug that into my equation, y equals 3 times 2 plus 4, and I get y equals 10. So the ordered pair 2, 10 is also a solution. If x is negative 1, when I plug that into my equation, I end up with negative 3 plus 4, that is positive 1, so y equals 1 when x is negative 1. The ordered pair negative 1, 1 is a solution. Finally, the last piece of the table says the y value is 7. So this time they gave me a y value. I'm going to replace y equals 7. So I get 7 equals 3x plus 4. And this is something that I can solve for x. I'd have to subtract the 4. And then divide by 3. And I get x equal 1. So the point 17 is also a solution. So this table of values contains 4 solutions to the equation y equals 3x plus 4. Again, if you're given the x, you can plug that in and solve for y. And the same is true if you're given a y value, you can plug that in and solve for x. So now let's take these solutions and plot them in our coordinate system. The horizontal axis is the x-axis, or the x values. The vertical axis is the y-axis, or the y values. So the point 0, 4 has an x value of 0, so I start in the middle, and a y value of 4, so I have to go up 4. And there's the point 0, 4. The point 2, 10 has an x value of 2, so I went over to 2, and then I had to go up 10, and in red is my point. That's the point 2, 10. The next solution, the x value is negative 1, so I go to the left 1. Y value is positive 1, so I'll go up 1. There's the point 1, or negative 1, 1. And finally, my last solution, x is 1, so I go over to the right 1. Y is 7, I'll go up 7. So I've plotted all of these solutions, and notice that they happen to lie in a straight line. That's not a coincidence. Anytime you have a linear equation, the solutions will always lie in a straight line. And in fact, if I connect the dots of these solutions and draw a line, this line represents every single solution to that linear equation. Every single point on this line is a solution to that equation. So linear equations describe how two different variables are related, how an x and a y value are related. And the idea is the x value could actually be anything, and then you get a corresponding y value. So our goal is to eventually talk about, well, how can we write these equations of lines? And so I need to define something called slope first. And slope describes the slant, or the way that the line is increasing or decreasing. We define slope to be rise over run. I'll explain what I mean by that in a minute. Or change in y over change in x. And that can also be written as the formula y2 minus y1 over x2 minus x1. All right, so let's go through that definition kind of piece by piece. So the idea is if I pick 2 points on a graph, and so let's just look at this first graph. I'm going to just choose 2 points. You can choose any 2 points, but it's helpful to pick points that actually go through the corners of the boxes. So slope describes how do I have to move to get from one point to the next. So the rise is how much do you have to move vertically. So if I'm moving from left to right, let's see, it looks like I have to actually go down 2 units, and then I have to go over to the right 3 units, and that will take me to the next point. So again, the rise is the amount that you have to move up or down. In this case, because I have to go down 2, I'm going to say my rise is negative 2. And the run is the amount that you have to move horizontally. To the right would be positive and to the left would be negative. So I had to move 3 units over to the right, so the run is positive 3. That means my slope is negative 2/3. Negative 2 over positive 3. Now, had I moved in the other order, I would still get the same answer. What I mean by that is, notice if I started with the point on the right, I would have to go up 2 units and then backwards 3 units. In that case, my rise would be positive 2, and my run, because I'm moving to the left, would be negative 3. When I divide my rise over run, I would actually get the exact same slope. Okay, so slope is rise over run. That can also be thought of as change in y over change in x. Let's look at the same problem to see how that second definition works. So the first point I looked at is actually the point 0, 4, and the point I compared it to is the point 3, 2. X is 3, y is 2. So we could say that our first point, 0, 4, is our x1, y1. And our second point, 3, 2, is our x2, y2. Then we can actually compute the slope by subtracting the y values. y2 minus y1 would be 2 minus 4. And x2 minus x1 would be 3 minus 0. And if I go through and do the math, I get the exact same answer, the same thing that my graph paper showed me. My rise is negative 2, my run is positive 3. All right, let's look at one more example. I'm going to pick 2 points, And again, I'm going to try to pick points where the line goes exactly through the corner of a box. So here's 2 points. I can find the slope graphically by counting the boxes. How much do I have to go up and how much do I have to go over? In this case, the rise, the amount I have to go up, is 4, and the run, the amount I have to go over, is 3. So that means my slope is 4/3. Now, one thing to notice is the line on the left is decreasing or going down. It has a negative slope, whereas the line on the right is increasing or going up, and it has a positive slope. That is always true. Lines that are decreasing have negative slopes. Lines that are increasing have positive slopes. Now, because of that second formula, we can find the slope even if we don't have a graph, even if we don't have a picture. For example, if I want to find the slope of a line that passes through the points 4, -3, and -2, 1, I don't actually have to draw a picture. I can use the second part of that formula, and I'll just call the first point my x1, y1, and the second point my x2, y2. My formula says slope is change in y over change in x, and so I can just plug the numbers in. y2 minus y1, -1 minus -3, over x2 minus x1. In the numerator I get 2, in the denominator I get -6. I'm going to reduce that to a -1/3. Let's do one more slope problem. This one is an application. It says a university researcher is conducting an experiment on a bacteria colony to test the effectiveness of a new antibiotic. 3 hours after the new antibiotic is administered, the population is 11,500. 2 hours later, the population is 9,250. Part A says find the slope. So actually the words don't even matter here. We have a formula for finding slope, and they've given us 2 points. We can say the first ones are x1, y1, and the second point is our x2, y2. And then this problem is exactly like the one we just did. We're going to take our change in y and divide that by the change in x. 9,250 minus 11,500 is -2,250. 5 minus 2 is 3. And I end up getting -750. Now, slope describes whether a line is increasing or decreasing. In this case, the line would be decreasing. But it also gives us information about the rate of change, how variables are changing. Notice that the numerator, the numbers that we took on the top, were population numbers, amount of bacteria. The numbers on the bottom, the denominator, those were times or hours. So the units of this slope is actually population per hour. Now, because the slope is negative, we know that the line is actually decreasing. So we can say that this population of bacteria is decreasing at a rate of 750 bacteria per hour. So again, slope gives us information about how something is changing, in this case, how the population is changing with time.